Consider our previous example where we had 2 points. P naught was 2, 4, negative 1, and P was 5, 0, 7. From this, I know that V is, 3, negative 4, 8, because 5 minus 2, 0 minus 4, 7 minus a negative 1. And x is going to be equal to 2 plus 3t, my initial point, x naught, plus t times v, so there's my 3 times t. Y is going to be 4 minus 4t, and z will be a negative 1 plus 8t. So then the symmetric equations are then x minus 2 over 3 is equal to y minus 4 over a negative 4, which is equal to z plus 1 over 8. So now I have those symmetric equations worked out. So what good are they? Well, let's fit around with these for a little bit. First thing I want to do is I want to take a look at the fact that the line will intersect the xy plane when z is equal to 0. Well, when z equals to 0, what I end up having for my symmetric equations is I now have x minus 2 over 3 equals y minus 4 over negative 4, which equals z is 0 and 8. See, now I can solve the equations. And I'm going to solve this one by one. I'll take x minus 2 over 3 has to be equal to 1/8. That implies that x minus 2 is equal to 3/8, which means that x is equal to 3/8 plus 2, which is 16 plus 3 is 19/8. Well, I'm going to do the same thing for y. I'll have y minus 4 over a negative 4 equals 1/8. That means that y minus 4 equals a negative 1/2. So y equals a negative 1/2 plus 4, which is 7/2. Therefore, the line intersects the xy plane. Plane at coordinates x is 19 over 8, y is 7/2, z is 0. So I now have the coordinates where the line will intersect the xy plane. Now I can repeat this and do the exact same thing for when x equals 0. When x is equal to 0, that's going to tell me where the line is going to intersect the yz plane. Well, when x equals 0, remember I'm working with these symmetric equations. When x equals 0, what I end up with is negative 2/3 equals y minus 4 over negative 4, which is equal to z plus 1 over 8. Now, doing the arithmetic and solving, I end up with the point 0, 20 over 3, and negative 19 over 3. Now, obviously, I can repeat this one more time. For y being equal to 0. And when I do, I'm going to end up with the point 5, 0, 7. And that should not be a surprise because we already knew 507 was in fact a point on the line. We knew that. So the symmetric equations will actually allow us to find coordinates on the line given any single value of x, y, or z. So let's just suppose for a moment, let's just go ahead and say I want to know where I am when x equals 2. When x equals 2, from the symmetric equations, I have 2 minus 2 over 3 equals 0. And that has to be equal to y minus 4 over 4, negative 4, which has to be equal to z plus 1 over 8. Well, the only way that can happen is if y is equal to 4 and z is equal to negative 1. So with the symmetric equations, given a value for any of the three variables, x, y, or z, I can figure out the coordinates of where the line is. Oops, negative 1.